Hello my friends, and welcome back. In today's video, we'll be taking a look at undefined behavior in Rust. I'm going to use an example from Komorebi, the tiling window manager for Windows, which is written in the Rust programming language. Because last week I came up against an undefined behavior bug in this project. And thanks to a number of very smart people on the internet who came to my aid, this was quickly resolved. So what is undefined behavior, right? Undefined behavior is the result of executing a program whose behavior is prescribed to be unpredictable in the language specification to which the computer code adheres. A simpler definition is maybe when the compiler allows your code to compile, but all bets are off when it comes to the actual behavior. So let's take a look at the commit that introduced this undefined behavior bug, and we can, why don't we show that in real time? So this was the commit. I'm going to check this out and build it. I'm going to have to turn off Komorebi, and we'll do just install target Komorebi. Hopefully this doesn't take too long. So we'll install the target to get the release build, and we will run the debug build directly using cargo run. So that is the release build installed, and now we'll do cargo run Komorebi locked. So we'll run this and we'll see that we don't have any issues, right? And if you watch the last video, at the end of the last video I was like, yeah, this is awesome, this is working, there are no issues, right? Everything is green, no errors, everything looks good. However, if I run Komorebi, the release build, you can see here we have error at init, enum display devices, the operation completed successfully, not a great error, but that's fine. And then the next error immediately after is the system could not find the environment option that was entered. So it looks like the window manager is still working, right? But we have a problem here now because the device and the device ID for both of my monitors has not been populated. And yeah, we kind of need that for this new feature that we're working on, right? The feature where you are able to set the index position of each monitor by its device ID. So once again, we'll go back to the debug build. I'll run the same command to look at the output, and here, like, okay, the device IDs are here. Something is kind of fishy, right? That's really weird. Why does it work on the debug build but not on the release build? That, my friends, is undefined behavior. See, I don't know, like, this is the first time I've ever come up against an undefined behavior bug in Rust. It's so uncommon, I would say, if you're just using safe Rust, that honestly I don't even think about it. Even, calling the Windows RS crate and the Win32 APIs, usually I don't think about it. I haven't had to think about it until now. But yeah, I was kind of stumped on this. Like, I didn't even think, hey, this is an undefined behavior bug, until somebody pointed it out to me. I was like, huh, I don't know what's wrong. I was perplexed. So I asked on Mastodon, have you ever experienced an issue where calls succeeded when running debug builds, but failed when running release builds? The first reply I got was from Ian Douglas Scott, who said, I'm not familiar with the Windows APIs, but you could set the op level and confirm that's the issue. That's the main thing that differs between debug release by default. If you're calling unsafe functions, it's expected that misuse may result in things that break with optimization, but seemingly work without it. So I did exactly this. And I realized that as soon as you set the optimization level to anything above the debug level, it starts breaking because some things are getting optimized. And you know, this is indicative of undefined behavior, because although it compiles, the behavior is not consistently guaranteed, you know, between these different optimization levels. I then received a reply from Ben Kimik, who is Safelin on GitHub. You may have seen Ben around. And Ben pointed to lines 248, 249, saying, I'm returning a pointer to a temporary that's about to be deallocated. Your if-let needs to pattern match on a reference. And if we go into the post that I posted on the Rust subreddit, the user TinyBreadBigMouth posted a more in-depth, I guess, explanation of what Ben wrote on Mastodon. So TinyBreadBigMouth says, your code contains undefined behavior. You create a dangling pointer here. I've given the variables different names for clarity. So why don't we get the original code? And then we can see how the renames were added for more clarity. So here it is. So let LP device, if let sum LP device equals LP device. Okay, so to make it clearer, this user renamed it like this. So LP device 1, LP device 2, LP device 3. So what is happening here is the way that this is being interpreted is let LP device 3 equals if let sum LP device 2 equals LP device 1. So this is saying that whatever is inside this option, so LP device 1 is an option, let's declare that as LP device 2, right? And then we go into this expression, and here, this LP device 2 is referenced here, but that LP device 2 goes out of scope at the end of this, right? So if you're saying LP device 3 is a raw pointer, PC, stir, whatever, you know, if we're saying essentially that we want LP device 3 to refer to something that went out of scope here, you know, that's just not going to work. And I think this is a much better explanation that I'll just read out. You're creating a pointer to LP device 2, which is a U8 array. Then LP device 2 goes out of scope at the end of the if block. So the pointer is pointing to data that doesn't exist anymore, right? So LP device 2 stops existing at the end of the if block, which is the beginning of the else here. Presumably in a debug build, the compiler isn't optimizing the function too much, and the memory happens to stay unchanged until you call enum display devices A. But in release mode, the error is exposed. The fix is just one character. I really like the way that this user kind of pointed out using it. Yeah, I really like when... One of the things I really like about Clippy and the Rust tooling is that errors and error reporting is very clear. And I like that users in the Rust community kind of... They just operate like that by default. So thank you for this, especially. I really liked. So, the fix is one character, so we're matching on a reference here. And the user explains, this time we matched on a reference to LP device 1 instead of moving the value. So the type of LP device 2 is now a reference to an array of U8 instead of U8, which is a copy. This means that we end up with a pointer to the array in LP device 1 instead of to LP device 2. So the data isn't dropped at the end of the block. Shadowing a variable doesn't change how long the variable lives, so this still works with or without the renaming. I thought this made a lot of sense. Like, this is such a clear explanation. Really appreciated it. So this has since been fixed, and somebody else mentioned that whenever you have differing behavior between debug and release, you probably have undefined behavior and need to run under Miri. So Miri is, and I believe Ben Kimik is somebody who works on Miri. No, where am I going? Oh, they don't have oh, yeah, here's the link. Here's the link. But however, process windows, there's a pending issue, which I'm not sure will ever actually be fixed based on what I read. There are certain Windows API functions. Let me just find that quickly. And it's annoying because it's like the first function called in our main, or one of the first ones, current process ID. So let me search for this quickly. There we are. Can't call foreign function get process ID on Windows. So I get this error also. And Ralph Young says standard process ID is not currently supported on any platform by Miri. In non-isolated mode, we can probably just call process ID on the host and use that. In isolated mode, we could return a fake ID, but I'm not sure if that could cause any problems. An isolated program cannot talk to other processes anyway, so there's nothing that ID can really be used for. So I can't run Miri. It would be good to run Miri on the whole code base. I'm sure there are probably other things that I've missed, but for now it's working. And so I ended up fixing this by just changing the function signature a little bit. So instead of taking this option U8 array, I just passed this const pointer directly, and then, we can wrap it in a PC stir so that we can use it in the call to enum display devices. This was very complicated. This was very complicated for the behavior being able to look up the device ID of a monitor. I feel like this is more complicated than it needs to be. But that is one of the challenges of working with legacy code, and I am sure that enum display devices is a very, very old piece of code in the Windows codebase. I think that is everything that I wanted to cover. So hopefully, if you have not been exposed to undefined behavior in Rust before, now you have an idea of, if you see a difference in a debug build and a release build, you probably have undefined behavior. And this is apparently a very common UB bug. The bug is easy to find once you've debugged it a few dozen times, but it's very common. So there's a pretty good chance, especially if you're working with the Win32 API, that you may introduce this bug. So now So now you know, just match on the reference. Match on the reference. Alright, let's head on over to the sponsors and say thank you, because the sponsors who support this project, I love you guys so much. You are all amazing. So I have 3 private sponsors here, if my memory serves correctly. Thank you all very much. Thank you also to Solomon, Julian, Evan, Maxwell, Red Lobster, Darian, Leandro, Alex, Kwang, Surefire, Michael, Pavel, and Hisayuki. Thank you so much for the ongoing support. If you too would like to become a sponsor, head on over to the sponsor page. You can be a one-time sponsor, a monthly sponsor. It's up to you. Even $1 a month, it makes a huge difference, and I appreciate it so very much. If however you are not in a position to become a sponsor, the very next best thing that you can do is head on over to the YouTube channel and hit subscribe. Actually, you're probably already there watching this video right now, so if you're not subscribed, hit subscribed. Yeah, we have hit 1,000 subscribers. Amazing. I never ever thought when I started making these videos that the channel would reach 1,000 subscribers, but here we are. That's amazing. I think we have now 400 or 500 watch hours left to become eligible for a cut of the ad revenue. So if you find these videos, I don't know, entertaining, relaxing, calming, informative, I mean, just keep watching them when they come up on your feed, right? You'll probably have noticed that pretty much all of the Komorebi tutorial videos, all of the NixOS tutorial videos have ads right now. And it will be really cool once we get to the point where the ad revenue from YouTube can also go into supporting the future of the development of Komorebi. There's also one new announcement. I had made a poll on the community channel asking what we should do for the Let's Plays. I can't see it here because I'm not logged in, but basically 70% of people voted to create a separate channel, which is what I have done. It is linked here. So if you enjoyed the Let's Plays, head on over to GZ Plays and subscribe. I've linked all of the playlists from GZ Codes here as well. And this next month we are going to be playing The Lies of P, which is an excellent game so far. We'll see how the rest of that goes. Alright, my friends, that is it for this time. I hope that whatever you will do today, you have a great day. Free Palestine, and I'll see you all back here next time.